Okay, the diagram below shows a plan for a window in the shape of a trapezium, which looks a lot like a trapezoid to me, but okay. Three sides of the window are 2 meters long. The angle between the sloping sides of the window and the base is theta, and theta is between 0 and pi over 2. Show that the area of the window is given by y equals 4 sine theta plus 2 sine 2 theta. Okay, so the area of the trapezium is going to come from 3 composite shapes. This triangle, this rectangle, and this triangle. If the side of this rectangle is 2, then the side across from it must also be 2. And then it looks like we've got, that's about it. So let's find the area of the first triangle here. We'll double that to get the area of the other triangle, and then we'll add it to the area of the rectangle. That doesn't look like a rectangle. Not in the slightest. Okay. This is 2, this is 2. All right, I don't know what this height is going to be, but I'm going to figure it out right now. Okay, so I have theta right here, and then I have hypotenuse of 2. I have the hypotenuse, and I would like the side that is opposite, because then I can get the height of the rectangle too. So I'm going to do sine. Sine of theta is equal to opposite over 2. I would just like to get kind of an algebraic representation of this opposite side here. So I'm going to cross multiply and get that the opposite side is equal to 2 sine theta. So it's no longer going to be called the opposite side. It is now going to be called 2 sine theta. He is being rebranded. So that means that this is going to be 2 sine theta. That means that this is going to be 2 sine theta. So if I need to find the area of a triangle, I'm going to, I'm going to do 1/2 base times height. So this is for the triangle. I'm just going to keep track of it over here. This is for the area of the triangle. I'm going to do 1/2 base. What on earth could the base be? I don't know. Let's figure out the base in a second. Times the height. The height is going to be 2 sine theta. Okay, so the base of this guy, I'm going to do kind of the same thing, right? Now I know theta, and I need the adjacent over the hypotenuse. So now I'm going to do the cosine of theta is equal to the adjacent, this guy, over the hypotenuse, which is 2. And then I'm going to cross multiply, and I'm going to get the adjacent side can be rewritten or represented as 2 cosine theta. I'm now going to change him from adjacent to 2 cosine theta. Okay, so the base is 2 cosine theta. Okay, so now I'm going to times these together, and I got area is equal to 2 times 2, which is 4 over 2 cosine theta, sine theta. I'm going to clean it up a bit. I got the area is equal to 2 cosine theta, sine theta. Oh, dang, that's a double angle, isn't it? Yeah, it is. It is the sine of 2 theta. Okay, so that's the area of the triangle. I have 2 of those. So times 2, and that's going to give me an area of 2 sine 2 theta. Okay, that's for the triangles. Triangles, let's just, triangles. Okay, and then for the rectangle, I have area is equal to base times height. So the base of this guy is 2, and the height of this guy is 2 sine theta. And there's only one rectangle, so I'm going to add everything together. I got 2 sine 2 theta plus 4 sine theta. And that matches this up here. It's just written in a different order. So there we go. Cool. What on earth am I supposed to do with that? Let's see. So we want a window to have an area of 5 meters squared. Okay, so if this is the formula that yields the area of the window, I want the area of the window to be 5. So I'm going to set this whole thing that I just found equal to 5. And then I need to find 2 possible values of theta. So let's graph this thing. I'm going to put in 2... This thing should be in radians, shouldn't it be? Yeah, from 0 to pi over 2. Okay, I'm going to change my calculator to radians before I start. Okay. 2 sine of 2 theta. I'm just going to change it to an x plus 4 sine of x. Enter. And then I want this to be crossing the line, y equals 5. Okay, and I have to find two possible values of theta, but I'm only from 0 to pi over 2. So let's change this to pi. Wait, I don't want to be in control, sorry. Oh my gosh, no, I'm sorry. Okay, I'm going to change this to pi over 2. And then this is going to be 0. All right, so I'm zoomed in a bit and I can see where the actual two solutions are happening. Boom and boom. Okay, so I got theta. I'm going to draw my little sketch, right? It's from 0 to pi over 2. I've got the graph and it goes like this. And then I've got another line, y equals 5. And then I've got the equation. What was the equation? Oh, they called that equation y? Okay, so then I have to change the name of this. I'll just call this f of x equals 5. And then this is going to be y equals 4 sine theta plus 2 sine 2 theta. And we've shown the two intersections to be theta equals 0 0.855. Nope, he's 1. Theta equals 1.25. Okay, so theta equals, oh, actually 855, that's going to round to 856. Silly Mrs. Spellcheck, you are so silly, 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 silly. How'd you get so silly? Okay, these are my two solutions. Cool. Okay, so for part C, John wants two windows which have the same area A but different values of theta. Find all possible values for A. Okay, so A, remember, is the area, and we can find the area using the function 4 sine theta plus 2 sine 2 theta. So we're going to look at the same thing that we just graphed earlier, right? Except now let's think about what the graph has for us. What can the graph tell us? Okay, so let's make this a little more easier to see what's going on. I want it to be like spread out more. Okay, there we go. So I need to have two separate windows, but they need to have the same area A. Okay, so where are, or think about it like this. If we have a horizontal line, right? And I start that horizontal line at the bottom of this graph and I scan up, where do I start getting two solutions? Right about here, right? And then I keep having two solutions where there's two separate values of theta all the way up until I hit the tippy top of this maximum piece here. So let's find the maximum of this thing. Okay, so it looks like it's happening at about 5.2. We are not including 5.2 though, because at 5.2 there is only one solution. And then let's find the first part where this guy starts having two solutions. That's going to be this point right here. I'm not quite sure how I'm going to find that. Let's do the table. Control T. Let's ask the table. We're going to change it from auto to ask. Okay, and we're going to ask it what's happening at pi over 2. Okay, so we are going to start having two solutions when y is 4. And we do have two solutions right there. That piece is included in the graph, right? Look at the original interval. We are including, oh wait, hold on. We are not including pi over 2. Okay, so we are not including that 4 in there. Okay, good to know. But yeah, between 4 and 5.2, those can be all the possible values for the area where we have two distinct values of theta. So I would just draw my little sketch of the graph, right? And I would be like, okay, so right here at, what was that point? 1, oh, pi over 2, that's right, pi over 2, 4. And then it's an open circle because we're not including the endpoint of the interval. We started having two distinct solutions, right? And then we kept having two distinct solutions until we got to the tippy top. Oh, that's not the tippy top. Until we got to the tippy top, where we ended up just having one solution. And that happened at, what was the point? 1.047 to 5.2. Okay, so this would be our answer for where we would find two different values of theta that yield the same area. Oh, you're just